In the previous video, we already compared the efficient versus inefficient situations on a PPF graph. We said that everything on the PPF would be efficient. That simply means the economy already made the very best use of its resources. And everything below the PPF would be inefficient. In other words, the economy should be able to do better than what it is doing now. Okay, and here we're going to continue talking about opportunity cost, how the opportunity cost can be shown on a PPF graph. If you remember, in chapter 1, we already introduced the concept of the opportunity cost. We said opportunity cost means the pleasure or the benefit we could get from the second best choice, or what we decide to give up. Now here we're going to give you a numerical example on the PPF to show the opportunity cost. Okay. All right, here I already made this PPF graph. Again, with the cars on the vertical axis and potatoes on the horizontal. And we specified 4 combinations between the cars and the potatoes along the PPF. Okay, so here I should label these. This is the economy's PPF. Okay, production possibility frontier. So all 4 combinations from A all the way to D are efficient because they're all on the PPF. In other words, here we're not going to talk about any inefficient cases. Okay, it's all efficient. Now, suppose the economy starts from point A. That means it puts all the productive resources into the auto factories producing cars. And we know that there would be 60 cars produced. Okay, so that's what happens at A. And suppose the economy decides to move from A to B, probably because people in that economy want to have some potatoes. Okay, they believe they can give up some cars. So here we are moving from A to B, again along the PPF. Okay, now what we want to ask you is, what would be the opportunity cost? Okay, let me write it here. OC stands for opportunity cost of a potato when the economy moves from A to B. Okay? So what would be the opportunity cost of a potato when the economy moves from A to B? We know from the graph that from A to B, the economy used to produce 60 cars. Now it produces only 40 cars. In other words, it gives up 20 cars during this process, right? So it's 60 minus 40. Okay? But this is not really the opportunity cost of a potato, because during this process from A to B, the economy gains 100 potatoes. So to be able to find the opportunity cost of a potato, we need to use 60 minus 40 divided by 100. Or let me write it this way. 100 minus 0. So 100 would be number of potatoes at B. 0 would be the number of potatoes at A. Okay, so this way we can find how many cars the economy gives up per potato. Okay, so here it's 20 over 100, so it's going to be 0.2. Right, it's going to be 0.2 cars per potato. Okay, 0.2 cars per potato. Now, suppose the economy continues to move from B to C, so probably they want even more potatoes. Then what's going to be the opportunity cost from B to C? Now here we know that from B to C, the economy gives up another 20 cars, right? Because it used to produce 40. I'm sorry, it used to produce 40 cars at B. Now it only produces 20 cars at C. During the same process, it gains 40 potatoes. It used to produce 100 potatoes at B. Now it produces 140 potatoes at C. So let's do the math here. So the number of cars given up would be 40 minus 20. Okay. And the number of potatoes it gains would be 140 minus 100. Okay. So here it will be 20 over 40. So it's 0.5 cars per potato. Okay. All right. Now let's do one more. The economy decides to continue move all the way down to D. So from C to D, what will be the opportunity cost of a potato? Now we find that the economy from C to D gives up 20 cars. Okay, and number of potatoes it gains would be 150 minus 140. So here it's going to be 20 over 10. So it's 2 cars per potato. All right. Now, this is a pretty good chance for us to review the concept of opportunity cost. In chapter 1, we said opportunity cost is built upon another principle which says people face trade-offs, right? Like here from A to B, if the economy wants to have more potatoes, it has to sacrifice some amount of cars. Okay, again, the same thing happens from B to C and C to D. Okay, so here the opportunity cost tells us this trade-off the economy faces. Okay, and remember we said that we talk about the opportunity cost because we want to look at why the PPF is bought out, right? And the bought out thing, in mathematics, the bought out, okay, let me write it here. The bought out is kind of the layman's term. In mathematics, people say this curve is concave or concave down, okay, or concave in. But that's not an economic definition of this bowed out curve. The economic definition, we have to look at the opportunity cost. We find that from A to B, the economy gives up 0.2 cars for each potato. From B to C, that number increases to 0.5 cars each potato. From C to D, it becomes 2 cars for each potato. So here we find that the opportunity cost is actually increasing from A all the way to D, right? In other words, the economy gives up more and more cars to be able to get 1 potato. This is the economic definition of a bowed out curve. In other words, when we say bowed out, we automatically mean that the opportunity cost along this line from A to B to all the way to C and D is increasing. You have to give up more. Okay. So here we already finished our discussion about the opportunity cost, and the only thing we have not yet discussed is why it's bowed out. Okay, or again, if we do the proof by contradiction, why it's not bowed in. So here I want to leave that for you guys to think about. Okay. And what could be the economic reasons or intuition behind the bowed out curve. On the very next video, we're going to explain why.